What I was hoping is that each group would get to look at least two of the different types of math things, of types of single strings. The equations and inequalities, or the inequalities and expressions, or at least two of them. If you only got to one, that's okay. But I'm hoping we got to at least two. And what I want to do now, there are two more things that we're going to do. Okay? We're going to see, did we all come up with the same subcategories?
No.
So what I'm interested in is what different people saw as important here. So you can put pencils down, you can put cards down. You guys are doing really, really well. So how many groups actually looked at equations and came up with differences among different types of equations? How many groups looked at the equations and wrote something down for what makes some equations different than others? All right, so I want to start over here, and I want you guys to tell us something, and I can pull them out, or you can pull them out, something about how some equations are different than others. So, Maria, you want to come up and separate some? Shh.
Well, we believe that this one, and this one should be in a different group.
Uh-huh.
Cause
You're saying they're not equations?
No. Oh wait, what do you mean?
Oh, you said different group. I thought you meant.
Oh no, not like that. I meant like cause well, unlike the others, all of these are just variables, and they all happen to have a property in it. Like this one has the commutative, associative, and then the distributive property.
Does everybody know what she means when she says they have a property in it?
Yes.
Can somebody tell me what she means by they have a property in it, Brun?
Like the property of commutative, like commutative means it don't matter which way it goes. It's like multiplication. If you go forward or backwards, it'll be the same.
So can you give me an example of the commutative property that uses numbers? Just tell me and I'll write it.
5 times 3 equal 3 times 5.
People agree that this is commutative?
Yes.
To me it doesn't look like this.
Yes, it does.
X plus y is equal to y plus 4. 5 plus 3 equals 3 plus 5.
5 plus 3 plus 5.
Is that different than what Ron said?
Yes.
Yeah.
So what, are these both commutative?
Yeah.
What's the difference?
No. One has
Angela?
One has
Excuse me. So there's the commutative property of multiplication and the commutative property of addition. Which one's this?
Oh, commutative property of addition.
Good. Now, you said 5 and 3 and you said 5 and 3. Could I use different numbers?
Yeah.
Yeah.
Like how many different
4
numbers?
and
I could use,
You can use 3 different numbers.
I could use,
Like instead of 5 plus 3, you could do 7 plus 5 plus 3. And then it would
okay,
be,
but if I keep it in this pattern, a number plus another and then reverse it, what's another example of the commutative property?
7 plus 2 equals 2 plus 7.
Good. Can everybody come up with their own?
Yeah.
Are there enough examples that everybody could come up with one?
Yeah.
How many examples are there?
Infinite millions.
There are many, many. So, in a sense, this represents all of them.
But
And I think what we can say is that this is always true of the numbers, of two numbers, x and y. We can switch them, right? So this is always true. It represents something that's always true. And this is another property represented. What property?
distributive.
Associative.
Associative.
Yeah. And this?
Distributive.
Okay, so you're saying the properties. Can I call this the properties? Property equations?
Yeah.
Always true equations? What should I call it?
Property.
Property equations. They represent property.
Have properties.
Okay, so that's one type of equation.